Welcome participants in this online training session on SPSS 27. This is the basic level of the training. Today is the 10th day of this training, 20 March 2024. Time is 9 p.m. to 9:40 p.m. Myself, Sahid Bashir, I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab. What we have done previously, we have done a lot of contents that I have highlighted in yellow. So these are the contents we have previously done up till the option number 9. And today we are going to discuss the graphical visualization using SPSS. So we have covered up till the content 9. So these are the remaining contents that we are going to cover in the upcoming days, like mean comparison, correlation, regression assumptions or diagnostic, regression cases, exploratory factor analysis, discriminant analysis, cluster analysis, process by Hayes, like mediation, moderation, and power analysis, like sample size estimation. So we are going to cover these set of topics in the upcoming days. Today is the visualization using graph, and I have divided this topic into 2 days. So half of the graphs I would cover today, and half of the graphs I will cover tomorrow. So, what kind of graph we are going to cover today? These are histograms, scatter plot, and frequency distributions. So, in order to understand them, why they are used, what is the basic theory behind these graphs, and what is the application behind these graphs, why they are used, what are the basic assumptions, what are the requirement of the data or the type of variable in these graphs, I will let you know first. Then I will try to explain the visualization of these graphs using SPSS 27. So first in this series is histogram. So what is histogram actually is, and why it is basically used? Histogram with its different types, a histogram is a graphical representation of distribution of data set. So using the histogram, you basically try to find out the distribution of your data set that you are going to use. The most favorable distribution of your data set is called the symmetric distribution, and it is also known as the normal distribution. It looks like a bell-shaped curve. So whenever your distribution of data set using histogram is looks like a bell-shaped curve, it's mean a symmetric or normal distribution. It is used, normal distribution is used for normality of your data, especially when you want to consider the validity of your estimates, whether your estimates are valid or not. So in this level, in case of symmetric distribution, your mean would become equal to the mode, and mode equal becomes to the mean. It means your measure of central tendency becomes equals to each other. So it is a case of symmetric distribution. So it is a favorable scenario when your histogram shows the shape like symmetric. In other unfavorable conditions or unfavorable conditions, it may shows the negatively skewed or positively skewed distribution. In case of negative distribution, the shape of the distribution looks like this, that the tail of it would be towards the y-axis, or it is a long tail. It becomes a long tail from the left side, you can say. In that case, your mode value would become higher, while median and mean value would become the lower one. So, in case of positively skewed distribution, its tail would be on the right side. So your mode again would become the higher one, but median and mean value would be greater than your mode. So you need to understand that in case of positively skewed distribution, your outliers might be on the left end, while in case of negatively skewed distribution, your outliers may be at the right end. So you need to understand these shapes. So to determine whether the distribution is right skewed or left skewed based on the mean and standard deviation, we can consider the following. In case of right skewed or positive skewed, this is the right skewed or positive skewed distribution. If the mean is less than the median, if you see here the mean, this is median and this is mode. So if the mean is less than the median and the tail of the distribution extend more to the right side, the distribution is called right skewed. In case of left skewed distribution, if the mean is greater than median and the tail of the distribution extend more to the left side, you just need to understand that in case of negative skewed, your distribution is left tail, and in case of positive skewed, your distribution is right tail. So you just need to understand that in case of symmetric distribution, it is looks like a bell shape. So we need to have a bell-shaped distribution in order to claim the normality of our data. So which type of data require histogram? If you want to create a histogram, which type of data you can use? You can use continuous data or scale-based data that we have measured using scale measure. So histogram are particularly useful for visualizing the distribution of continuous data, such as age, income, test score, etc. You can also use the interval data like variable measured on interval scale benefited from histogram. We can also use discrete data like continuous data. So whatever you have measured in terms of variable, you can use here for the histogram. So I will let you know how we can prepare the histogram, but first you need to understand some basics. So why we prepare histogram? The first purpose is to see what kind of distribution is involved in your data set. So it will provide a visual representation of the distribution of data, whether it is bell-shaped distribution, whether it is right skewed or left skewed. So first purpose is to know the distribution of your data. The second purpose is to identify the pattern. Histogram helps identify pattern, whether it is normal distribution, whether it is skewness, or whether it is multi-modality, whatever the case may be. Then it also helps us to know whether there is an outlier in our data set. So outliers can stand out in histogram. I will let you know if there is an outlier in our data set, it will be pointed out automatically. So histogram helps you to identify the potential outliers in your data. So outlier, what are the outliers? Outliers are basically the extreme value which are away from your average values. So they can easily be identified with the histogram. Then you can explore your data. They are essential for exploring the central tendency and variability of the data. So what does histogram tells you? It will let you know the shape of the distribution, whether it is symmetric, whether it is skewed or bimodal or multimodal. If it is bell-shaped, we call it symmetric, which indicates the normality of your data. So it will validate your estimations for further consideration. In case of skewed distribution, whether it is right skewed or left skewed, it may have some concerns regarding the further estimation. So we need to rectify our data in case of skewed distribution, or we may consider some other procedure that we may require with skewed distribution. In case of biomodel or multimodal, multiple peaks indicate multiple subgroups. So if your data has some multiple groups or multiple subgroups, it will indicate you biomodel or multimodels. The another thing is central tendency. It will let you know the mean or the median. Central peak points towards the mean position of the median can be observed. Then you can also understand the variability of your data. Width of the distribution reflect the variability. I will let you know how you can understand this. Then you can identify the potential outliers. If you find out some isolated bars in your histograms, they will reflect some, you can say uh, they can reflect the outliers. So what are the interpretation guideline? If I need to interpret the histogram, what kind of interpretation I can create from the histograms? So I can identify whether if the curve is bell-shaped curve or approximately symmetrical, I can claim the distribution is normal. Then if it is not normal, I can claim whether it is right skewed or left skewed, which suggests a symmetry of your distribution. I can also claim that the peak near to mean or median through central tendency, I can let it know if the spread is wider, I can claim higher variability of the data, but if the spread is narrow, I can claim the narrow variability of the data. Then, if I identify some isolated bars, I can let it know that there are some potential outliers in the data. So let me show you how we can use the histogram here. So let me open some data set here. For example, this was our file. Previously, we used a data set that I have already shared with you. It was a practice data set that we previously used. So I am going to use it again for your understanding of histogram. How can we create a histogram and how can we interpret the histogram of a variable? First thing that you need to understand what kind of variable we can have. We can have continuous data, we can have interval data, we can have discrete data. So let's suppose we are going to use the data of the composite variable that we have previously used. So we have created some composite variable here in our yesterday session, like STT, LDT, ES, OS, FS, and PS. So let's suppose I am going to create uh, a histogram based on PS. So I go to the graphs, and here there are two options. One is the chart builder, and the second is the legacy dialog box. So if you want to create a histogram, there is an option of histogram here. And you can also create the same thing from chart builder too. So I will let you know how both options work. So what you need to do, you need to go to the graph. First, I will let you know the legacy dialog box. So you need to click on the histogram, and it is asking which variable you would like to use for your histogram. So let's suppose I am using project scheduling as a composite variable of our study. Uh, I put it here. I let it know. I let it know nothing. I just click on OK and let it show the graph. And you can see here a graph. So what kind of graph it is? If I do compare with my pictures here, if you see these pictures, if you see the graph like this, a bell-shaped graph, which is basically bell-shaped from the center of the data. It is symmetric graph, which is basically most favorable for us. But if it shows uh, a tail on the left side, it is negatively skewed. If it shows a tail on the right side, it is positively skewed. So first, let me know what kind of graph is this. Yes, Rabia and Miss Hina, please indicate which kind of graph is this.
Sir, left skewed.
Yes, this is left skewed. Plus, there is another category of graph. This is, if you remember, I have told you about the type of graphs. Yeah, yes, this one. Biomodel or multi-model. When you have multiple peaks indicating multiple subgroups. Have you noticed that there are some multiple peaks here? This one
Yes,
is
sir.
indicating a peak and this one also indicating a peak. So this is basically left skewed with multiple peaks graph here. So we can claim here that it is left skewed, negative skewed with biomodel graph, histogram. And the second thing, if you see here, the variability of the data. These are the bars, but there are some gaps here. Like you can observe here, the gaps. These are the variation, and it has also calculated some standard variable here, 1.073 and a mean value of 3.45. So it is indicating with the help of the calculation that this is not normal data. So we can copy here, we can interpret here. For example, I would like to show you, I need to create here a Word document for interpretation. We can put it here. We have created a histogram for PS. Let it be a figure one histogram for project success for PS. All right. Now I need to interpret this graph. So how can I interpret? The first thing, if you notice here, the graph is not symmetric. All right, because this is not indicating any bell-shaped curve. So we can say here the figure one above indicates a non-symmetric graph. It is left skewed or negative skewed graph with biomodel shape because it is indicating multiple peaks or two peaks, two different peaks. Therefore, it is concluded here that project success variable is not showing normality here. That the data of project success variable is not showing normality. All right, this is the interpretation of this graph. Similarly, we can check the histogram of the other variables too. For example, we have checked the normality of only one variable. We can use the similar procedure. We can go to here and we need to put another variable here. For example, SDT. Click OK and you will
सर
see another.
एक्सक्यूज मी
Yes.
सर, जब हमने कल कुर्टोसिस और वो स्क्यूवनेस का कुछ लगाया था तो उसमें तो ये शो कर रहा था कि ये डेटा नॉर्मल नॉर्मल है।
uh,
नॉर्मेलिटी ऑफ डेटा शो कर रहा था।
there are multiple criteria that you can use. It depends which criteria validate the normality in what shape. So this is critical analysis. There are some other instance too. I will let you know in the future. It depends upon whatever the criteria you are using. You need to justify with a specific reference that this criteria that you are using for normality is basically supported by this evidence. So there are multiple criteria. Sometimes things becomes normal with some criteria and things becomes not normal with another criteria. So we need to understand what are the different criteria for assessing the normality. So graphical procedure is showing that the data is not normal, while the estimation procedure is showing that it is normal. So we need to present whatever the criteria is saying. Like in yesterday, Miss Hina was asking me about whether we should present these kinds of statistics. Is it compulsory for us to present these kind of statistic in front of the public? So it is up to you. If you feels that the data shows some normal values, you can present it. Otherwise, my suggestion is that you should not present if the data does not show normality. Some criteria shows them as a normal, and some criteria may not show them normal. So it is up to you. All right. Uh, let me
ओके
let
सर।
me let me use another procedure through the chart builder. If you would like to use the chart builder procedure, how can you use it? Let me explain you again. Go to the graph, go to the chart builder, click on OK, and there are a lot of options here. If you see here, bar chart, line chart, area, pie, polar, scatter, histogram. So let me use histogram first. If I need to use the simple histogram, you just need to double click on it, and it is asking what kind of data you want to use here. So I need to use here a data for y-axis and x-axis. So let me use ES as a x-axis, and let me use SDT like this. Now it is showing another thing here. You need to have two different variables for creating this. But for example, let's suppose I just need only my PS variable here. It is not going to show me anything. So I need to have two variables for indicating this. Let's suppose this one is independent variable and this one is dependent variable. Now I click OK and see what will happen here. It shows nothing here in case of histogram. So it means if you are going to use the histogram, you should preferably choose this procedure, because histogram requires only one variable. You don't need to use other variable, while the chart builder requires you at least two variable in order to create a model. But in this case, the model is not being created here, so we don't need to use it. So the next thing that you need to understand is the scatter plot with its different types. So what is scatter plot? A scatter plot is a type of graphical presentation that displays individual data points on two-dimensional graph. Now, this graph can be created with the chart builder because it requires two-dimensional graph. each point on the graph represent the values of two variables. So in this case, we need two variables if we want to create a scatter plot. So whenever we need to create a relationship between two variables, one we need to show on x-axis and the other one we need to show on y-axis, we can create a scatter plot. So this is what we can create from the chart builder as well as from a graphical procedure that I have created. So what is the purpose of creating a scatter plot? The first thing is that you need to understand here is the visualization of relationship, that what kind of relationship really exists between two variables. If I want to see that whether one variable is really related with another variable, I need to create a scatter plot. It also identify the pattern, whether there is a positive pattern, negative pattern, or whether there is some potential outliers here in the data. It also assess the correlation between two variables, whether they are positively correlated or negatively correlated. And it also helps you to predict one variable on the basis of another variable. So, what does a scatter plot tell? It will let you know the direction of relationship, whether there is a positive relationship or a negative relationship between both variable. It will also let you know the strength of the relationship, whether there is a strong relationship or whether there is a weak relationship. It will also help you to identify the outliers, and it will also help you to identify whether there is a linear relationship between variables, if it is indicated by a straight line, and whether there is a non-linear relationship between the variables. So uh, let me show you how we can create a scatter diagram. So I will let you know the both procedure. First, I will let you know from the legacy dialog box. You have the option of scatter or dot diagram from here. You need to use simple scatter. Just click on it, define it. It is asking which variable you want as a dependent variable. So let's suppose PS is the dependent variable, which is we are going to put in y-axis. Now it is asking which variable is independent. So let's suppose I am using SDT as a independent variable. So you just need to click on OK, and it will show you a graph like this. So can you let me know whether this is indicating a positive relationship or negative relationship? Yes, Rabia or Miss Hina?
Say positive.
Positive.
Positive relationship.
Yes, a positive relationship. When the relationship looks like this is a positive relationship. And in order to verify whether it is a positive or not, you can right click on this. All right. You just need to double click. Yes, you need to double click over this graph. It will show you a new window like this, and you have an option of line fit here, a reference line from the equation. You just need to click on it, and it will create a line like this. Now, this is a reference line, and it will let you know whether this relationship is linear or not. So you can create a scattered diagram like this. And you have a lot of option, a fit line also. You can create a fit line too. Uh, this is the option of line fit. It will let you know whether your data is basically linear with your central line or not. So this is how you can create your linear graph like this. So it is showing the linearity. The another way to create this graph is by going graph and chart builder. So here we can easily create this graph. We just need to click on the scatter, click on this one, double click, and it is asking whether you want to consider your data on STT and this one. So you need to drag your dependent variable here in y-axis, and you need to drag your independent variable in x-axis. Then you need to click on OK button, and it will create the same graph that we have created. So again, if you want to put here the line, just double click this one, and it will show you like this. And you need to click add line fit, and it will fit a line. It will show a line fit here. You can also add some other lines here, but if you wanted to. So this is how you can create a scatter diagram between the variables. The next thing that you need to understand is the frequency distribution, how you can create the frequency distribution. Frequency distribution with its different types. A frequency distribution is a tabular or graphical presentation of the number of occurrences, frequency of each distinct value or range of value in a data set. So it is also a kind of histogram. So if you need to understand the frequency of a particular data, you can create the histogram for that data. So it provides a summary of the distribution of the values and allows for a quick understanding of the pattern and characteristic of the data. So what kind of frequency distribution you can create? You can create simple frequency distribution. It displays you the count or the frequency of each unique value in a single variable. It will provide you group frequency distribution, like organizes the data into interval and shows the count of the values within each interval. It also provides you the option of cross tabulation, which we have used previously. So it examines the frequency distribution of two or more variables simultaneously. So what kind of data required for frequency distribution? You can use any type of data for creating frequency distribution. You can use categorical data, like you can create categories of frequency distribution, particularly useful for summarizing and analyzing categorical or nominal data. You can create ordinal data uh, for frequency distribution. It helps to see the distribution of ranks or categories. You can use discrete numerical data, useful for displaying the distribution of discrete numerical value. So why prepare frequency distribution? In order to summarize your data. So if you want to summarize your data, you need to create the frequency distribution. You can explore the data range, central tendency, variability of the data. You can identify the pattern. You can identify the outliers in the data. You can prepare for further analysis this data set. So this is how frequency is considered. So let me show you the option that you can use here, like in graph builder. You have the option of bars for showing the frequency distribution. So you can use the simple bar chart for showing the frequency of the data. For example, I would like to see the frequency of PS. I need to put it in the category axis, and I need to click on OK. So it will show me the frequency of my data, that how frequently the data is basically used for how much frequency. You can see the counting of the data on the left side, and the variable name on the right side of the data. And it is showing that with the data 4.13 value, it is showing more values. You can also check the same procedure by each factor variable. Like you can go to the bar chart, simple bar chart, and you can put it for example, I would like to see for, let's suppose, PS1. This is just a factor variable. We need to put it here, click OK. and you will see that how many people have strongly agree, disagree, neutral, and so on. And you can see here that with PS1, majority of the people and more than 150 people are saying they are agree with PS1 statement. In the same way, you can create frequency distribution graph with any variable you wanted from legacy dialog box using bar charts. So let's suppose I would like to see STT1 in place of this STT1 as a reference variable. Click OK, and you can see how many people are here on the agreement box. There are more than 125 people who are agreeing with STT1. So in the same way, you can check the counting of your data, how many are basically representing which group. You can also check the gender variable here for counting how many are male and how many are female. For example, I would like to see the bar chart, symbol bar chart, and I would like to see how many are male and how many are female. So click OK, and you will see here the counting of male member and the counting of female member. There are more female, there are more than 300 are male, and more than 100 are female. So you can apply this procedure on any type of variable here. For example, I would like to see the education level of different persons. So I can see here there are more than 150 people are here who are less than bachelor. There are exactly 151 people here who are graduates, and there are less than 150 people who are basically the master's level. There is another way you can use the chart builder to create it. You can go the chart builder here. Here, the bar chart option you are provided with. You can use the simple bar chart here, and you need to provide it what kind of variable you are interested to use. For example, I would like to see, uh, I would like to see here as a Y, PS, and as a X, as a X as STT1. Now, what will it show? It shows a graph like this. Now, click OK, and you can see with STT1 and PS, you can see a combination of these graphs. So if you want to consider a single variable, you need to use the legacy dialog box option. But if you want to see a combination of two variables, you always need to use the chart builder option. So this is how you can create the charts. So do you have any question, Miss Hina and Miss Rabia, about today's session? All right. So let's meet tomorrow for further consideration. Till then, stay safe and stay healthy and stay happy. Thank you very much.